This conference will now be recorded.
Good evening. In today's class, we are going to learn differential equations. This is the next chapter. So the objective of this class is we are going to learn about three things. What is a differential equation and what is the degree and order of the differential equation? What does it mean? Then solutions of differential equations. There are two solutions we are going to discuss. One is general solution and another one is particular solution. So general and particular solutions of a differential equation. And then formation of differential equations. So these are all we are going to learn in today's class. First, what is a differential equation? Before that, before understanding the differential equation, before we should know what is a differential equation, we should know about what is an equation, right? What is an equation? Equations you're all familiar. Equations of the type like x square plus 3x plus 3 equal to 0, that is given here. I'll show to you. X square minus 3x plus 3 equal to 0. It is an equation, right? It is an equation involving x. It's a quadratic equation. What type of equation is this? It's a quadratic equation. It's a second degree equation. X square minus 3x plus 3. It is a second degree equation in the variable x. Here only one variable is involved. So it is a second degree equation or quadratic equation in x. Anything we can write like x minus 3. It's a first degree equation. Or y minus 3 I can say. Or xy minus 3 equal to 0. So these are all equations. Next, sine x plus cos x equal to 0. Here sine and cosine terms are involved. The second equation you can see sine x and cos x. So sine function and cosine function are involved here. So what type of equation is this? These are all trigonometric identities that you know, right? So this is a trigonometric equation. This is a trigonometric equation since it contains trigonometric identities, functions, sin x and cos x. What about the last equation, x plus y equal to 7? Here two variables are involved, x and y. Both are unknown. So if this equation is given to you, then we will solve it for x and y because there are two unknowns, x and y. So we will solve it for x and y. We will find the values of x and y. It is an equation. So anything we can, any problem, we can write it as an equation. We can write it as an equation. We can represent mathematically, we can represent it as a equation. Once you represent it mathematically, then we will be able to solve it easily. Otherwise, we cannot solve the problems, the real life problems. Any real life problems, you can represent it as mathematically, right? You can model the real life problems as a differential equation. You can represent the real life problems as a differential equation. Okay, so these are all equations, not differential equations. I said the second one is a trigonometric equation. If it contains log function, suppose log x plus 2 equal to 0 or log x plus log y equal to some 5. So here logarithmic functions are involved, log x and log y. So it's a logarithmic equation. Suppose if you have exponential term, e power x plus 5 equal to 0, e power x plus 5 equal to 0, it is also an equation. This equation contains exponential term, right? E power x plus 5 equal to 0. So these are all equations of several types. Okay, like that We can define differential equation also. So what is the difference between these two, differential equation and an equation? A differential equation is an equation. First of all, it is an equation which contains derivatives. Which contains derivatives. What do you mean by derivative? A function y is changing with respect to another variable. A function y. Okay, any function y. If any function y is changing with respect to another function. If it change with respect to another function, another variable x, then that is called the derivative of y. The derivative of y with respect to x. Any variable is changing with respect to another variable. Okay, that is known as derivative of y with respect to x. Suppose y is a function of x. Y is a function of x. For example, y equal to x square plus 2. Here y is a function of x. Y is depending on x. Y is depending on x means y is an independent variable. Sorry, dependent variable. Y is depending on x. So y is a dependent variable, whereas x is an independent variable. X will not depend on y, but y is depending on x. So y is a dependent variable, whereas x is an independent variable. Okay, so since y is depending on x, so y will vary with respect to x, right? The variation in y, we can measure the variation in y with respect to x. So the variation in y with respect to x is written as dy by dx. That's what derivative. That's what derivative. Okay, dy by dx, and that can be taken as g of x. It is also a function of x. Dy by dx will be a function of x, so that can be taken as g of x, another function of x. It's just a notation, g of x. Okay, so suppose y is a function of x. This is the given function. Y is a function of x, like y equal to x square plus 2. It can be anything. So y is depending on x. That means y is a dependent variable and x is an independent variable. Here two variables are involved. One is a dependent variable and another one is an independent variable. Okay, y is a dependent variable and x is an independent variable. So if there is a change in y, then there will be a change in x. If there is a change in x, then there will be a change in y, right? So if there is a change in x, then there will be a change in y. That can be represented mathematically as dy by dx, derivative of y with respect to x. Okay. Suppose if there is a change in x means, then that can be represented as dx by dy, derivative of x with respect to y in that case. Okay, we can represent in both the ways, dy by dx as well as dx by dy also we can write. So this is what derivative, and this is also a function of x, so that can be taken as g of x. So a differential equation is an equation involving derivatives. That is the differential equation definition. Okay. So a differential equation is an equation. Let us consider this equation. X into dy by dx plus y equal to 0. X into dy by dx plus y equal to 0. You consider this equation. X into dy by dx plus y equal to 0. What is this dy by dx? It's a derivative. Y with respect to x. So this equation involves derivatives. That is dy by dx. Therefore, it is a differential equation. So what is the formal definition? In general, an equation involving derivative or derivatives, more than one derivative, okay, of the dependent variable. What is the dependent variable here? Y is the dependent variable with respect to independent variable or independent variables. If there are many, that is called a differential equation. That is called a differential equation. So here, if you consider this equation, here Y is a dependent variable, Y is depending on X, so Y is a dependent variable and X is an independent variable. Okay, so it contains a derivative. It contains only one derivative, dy by dx, the dependent variable y with respect to the independent variable x, with respect to an independent variable x. So this is called a differential equation. A differential equation involving derivatives of the dependent variable with respect to only one independent variable is called an ordinary differential equation. Differential equations are further classified into two types. Differential equations are classified into two types. One is ordinary differential equation. Ordinary differential equation. Okay. And another one is partial differential equation. And another one is partial differential equation. Okay, what do you mean by ordinary differential equation? An equation involving derivative or derivatives of the dependent variable with respect to only one independent variable. With respect to only one independent variable. Okay, that is called ordinary differential equation. For example, 2d square y by dx square plus dy by dx the whole cube equal to 0. This is an ordinary differential equation. Why it is an ordinary differential equation? First of all, this is an equation and it is a differential equation because it involves derivatives d square y by dx square and dy by dx. Okay. Why it is called an ordinary differential equation? Because the dependent variable y is depending on x only. The only independent variable here. X is the only independent variable. Okay. Therefore, it is called an ordinary differential equation. Next, partial differential equation. What do you mean by partial differential equation? We have discussed ordinary differential equation. Then what do you mean by partial differential equations? There are differential equations involving derivatives with respect to more than one independent variables. Okay. If the dependent variable depending on more than one independent variables. More than one independent variables. In ordinary differential equation, we see only one independent variable, right? That is x here. But if we have more than one independent variables, for example, I'll tell you, z is a function of x and y. Z is a function of x and y. Here z is depending on x as well as depending on y. So z is a dependent variable, whereas we can see two independent variables, x and y. Both are independent variables. So we can see more than one independent variable in this case. So dou z by dou x equal to z is depending on x as well as we can differentiate z with respect to y also. So this kind of equation is called a partial differential equation. But we are going to study only ordinary differential equations here. We are going to concentrate only ordinary differential equation. These are the notations we are going to use in this chapter. Dy by dx, okay, dy by dx equal to y dash. Dy by dx is written as y dash and d square y by dx square. This is the second derivative, second order derivative. So this is y double dash and d cube y by dx cube is represented as the third derivative, y triple dash. Okay. For derivatives of higher order, it will be inconvenient to use so many dashes as super suffix. Therefore, we use the notation yn for nth order derivative. Okay, for the first derivative, I can use y dash. Second derivative also, I can use y double dash. Third derivative, I can write y double dash. But if you have higher order derivatives, like 7th derivative, 10th derivative, 11th derivative, in that case, I cannot put so many dashes, right? To avoid that, we are using this notation, d power ny by dx power n. Okay, so d square y by dx power 2, d cube y by dx cube, d power 4 y by dx to the power 4, like that. So these are all the notations we are going to use in this chapter. Okay, we have studied what is a differential equation. What is a differential equation? A differential equation is an equation involving derivatives. Involving derivatives. Okay. Involving derivatives where the dependent variable will depend on the independent variables. Okay. Differential equations are categorized as partial differential equations as well as ordinary differential equations. So there are two types of differential equations. One is ordinary and another one is partial differential equation. What do you mean by ordinary differential equation? Ordinary differential equation is an equation involving derivatives where the dependent variable will depend only one independent variable. Where the dependent variable will depend on only one independent variable. If it depends more than one independent variable, then that's nothing but partial differential equation. These are all the notations we are going to use it here. Next one is order of a differential equation. Next, we are going to define order of a differential equation. Order of a differential equation is defined as the order of the highest order derivative of the dependent variable. Okay. What is the definition given here? Order is defined as the order of the highest order derivative. Highest order derivative of the dependent variable with respect to the independent variable involved in the given differential equation. So highest order derivative. Order means order of the highest order derivative. So order of the differential equation means then you should find the order of the highest order derivative of the dependent variable. For example, consider the following differential equations. See the first equation, equation number 6, dy by dx equal to e to the power x. dy by dx equal to e power x. So this is a first order derivative, right? Y with respect to x. Only one time we are differentiating here. So we will call it as first order derivative. We are differentiating y with respect to x only one time. Y with respect to only one time. So this is known as first order differential equation. First order differential equation. Then we move on to the next one. We'll see d square y by dx square plus y equal to 0. See the seventh equation, d square y by dx square plus y equal to 0. Here, I am differentiating y with respect to x two times. Okay, first time if you differentiate y with respect to x, then you will be getting dy by dx. Okay, y is a function of x. So in the left hand side, I will be getting dy by dx if I am differentiating y with respect to x only one time. Okay, so this is the first order derivative. If I differentiate one more time, dy by dx, okay, I am differentiating dy by dx with respect to x one more time. Okay, then what I will get? I will get d square y by dx square. D square y by dx square. So here I am differentiating dy by dx with respect to x one more time. So I will get d square y by dx square. So this is known as second order derivative. Second order derivative of y with respect to x. That's what given in equation number 7. Now come to the 8th equation. What is given here? d cube y by dx cube. d cube y by dx cube plus x square into d square y by dx square the whole cube equal to 0. So if you differentiate d square y by dx square, d square y by dx square with respect to x one more time, then you will be getting d cube y by dx cube. d cube y by dx cube, right? d cube y by dx cube. So this is the third order derivative of y with respect to x plus x square into d square y by, this is the second order derivative, whole to the power 3 equal to 0. That means d square y by dx square 3 times. It comes 3 times. Okay. So these are all the given equations. What we can tell from these equations? What do you understand from these equations? What we are learning? We are learning the order of the, we are defining the order of the differential equation. Order means you should see the highest derivative. Highest derivative, okay? In the above equations, we see that the highest derivative of first, second, and third order, right? So in this sixth equation, this is the first derivative. In seventh equation, this is it contains second derivative, second order, and in the eighth equation, it contains third order derivative. Therefore, the order of these equations, highest degree, right? Highest order derivative, highest order derivative. Here we have only one derivative, dy by dx. So highest order, it is 1. Okay. Then in the second equation, the highest derivative, this is the only derivative, d square y by dx square. So the order of the highest derivative is 2. The order of the highest derivative is 2. And in this equation, the highest derivative is actually, here we have two derivatives. One is d cube y by dx cube and another one is d square y by dx square. Right? d cube y by dx cube and the other one is d square y by dx square. Therefore, highest order derivative is d cube. d cube y by dx cube. That is the highest order derivative. So order of the first equation is 1 and order of the second, this is 2. Order of the third equation is 3 because the highest derivative is d cube y by dx cube in this equation. Okay. Next, we are going to define degree of a differential equation. Degree of a differential equation. So to define the degree of a differential equation, the differential equation must be a polynomial equation in derivatives. The differential equation must be a polynomial equation in derivatives, that is y dash, y double dash, y triple dash, etc. For example, consider the following differential equations. See differential equation 9. Equation 9 is d cube y by dx cube plus 2 times d square y by dx square the whole square minus dy by dx plus y equal to 0. Okay, so I said to define the degree of a differential equation, the differential equation must be a polynomial equation. Yes, of course, this is a polynomial equation in y dash. Y dash means dy by dx. Y double dash, d square y by dx square. Y triple dash, dqy by dx cube. Okay, so it's a polynomial equation in derivatives y dash, y double dash, and y triple dash. Consider the 10th equation. This is also a polynomial This is actually it's a polynomial equation. In y dash, not in y. This is a polynomial equation in y dash because we have dy by dx the whole square plus dy by dx minus sine square y equal to 0. So it is polynomial in y dash, not polynomial in y. Okay, polynomial in y means you will be having like this y cube minus y square plus y plus 2y equal to 0 or some value, some constant value. Okay, it's a polynomial, third degree polynomial, third order polynomial equation. Okay, so it means that third order polynomial means you'll be having y cube term, y square term, y term. Even if y square term is absent, that will also considered as cubic polynomial. Even if y term is missing, we will consider that as a cubic equation. Okay, we will consider that equation as a cubic equation. Is that clear? So polynomial in y means there will be y cube, y square, y. If any of the term is missing, then that can also be considered as the polynomial equation in y. But here it's not like that. This is polynomial in y dash because we can see dy by dx the whole square and dy by dx. So it is polynomial in y dash. This is y dash square or dy by dx the whole square plus y dash minus sine square y equal to 0. Okay, so this is polynomial in y dash, whereas the first equation is polynomial in y dash, y double dash, y triple dash. What about the last equation? See, dy by dx plus sine of dy by dx equal to 0. This is not a polynomial equation. This is not at all a polynomial equation because this is the second term in this equation involves sine of dy by dx. Okay, so this is not a polynomial equation. I will tell you one more example. Y dash equal to tan x. Y dash equal to tan x. This is a polynomial equation. Dy by dx equal to tan x. Yes, it's a polynomial equation, but tan of y dash or tan of dy by dx equal to some x plus y. It's not a polynomial equation because this is tan of y dash. Tan of dy by dx. That is not a polynomial equation. That we cannot say that it is polynomial in y dash. Okay, because it contains the term tan of some trigonometric function of the derivatives. Okay, sine of the derivative, tan of the derivative, cosine of the derivative. That is not a polynomial equation. So to define the degree of a differential equation, first of all, it should be a polynomial equation. Okay, so why we have to check that? If it is not a polynomial equation, then the degree cannot be defined. If it is not a polynomial equation, if the given equation is not a polynomial equation, then degree of such a differential equation cannot be defined. Degree of that equation cannot be defined. So before writing the degree of the given differential equation, we should check that whether it is a polynomial equation or not a polynomial equation. Okay. So by the degree of a differential equation, when it is a polynomial equation in derivatives, we mean the highest power. It should be a positive integral index. Positive integral index means it's a whole number, not the decimal number. Okay, so highest power of the highest derivative. So what is degree? Degree means highest power of the highest order of derivative. Highest power of the highest order derivative. Order of the differential equation already we have defined. Order of the differential equation means highest order derivative. Highest order derivative. highest order d cube by third degree derivative or second degree derivative d square y by dx square, first degree derivative dy by dx. So that is what order. How many times you are differentiating is the order. How many times you are differentiating the given equation with respect to x, that is what order. I am differentiating 5 times, so that is the highest derivative. For this type of for this particular function, I am differentiating 5 times with respect to y with respect to x. I am differentiating y with respect to x n times. So that is what order. How many times you are differentiating. But degree is not like that. Degree is highest power of the highest order derivative. Highest power of the highest order derivative. Okay. So in the first equation, the highest derivative is d cube y by dx cube. Here y is differentiated with respect to x 3 times. In the second term, y is differentiated with respect to x 2 times. The third term, y is differentiated with respect to x 1 time. So the highest derivative is d cube y by dx cube. I am differentiating y with respect to 3 times. Now see the highest power of this highest order derivative. It is 1. Okay. Even though we have d square y by dx square raised to the power 2, we will not consider that. We will consider only the highest order derivative. So its power, highest power is 1. Similarly, in the second equation, the highest order derivative is dy by dx. Y with respect to x only 1 time. But what will be the power? We have 2 terms. The same dy by dx. But what is the power of the equation? It is 2. Power of the highest order derivative. So it is 2. But it is not a polynomial equation. The 11th one is not a polynomial equation because it is sine of the derivative. Sine of dy by dx. We will not say that it's a polynomial equation. So we cannot define order for this equation. We can define order only for these two equations, 9 and 10. Its order is 1. Ninth equation. The highest derivative is d cube y by dx square. Its highest power is 1. And in the 10th equation, the highest order derivative is dy by dx and its power is 2. Okay. Next, order and degree of a differential equation are always positive integers. I told you, right? Order and degree, if defined for a partial differential, for an ordinary differential equation, are always positive integers. It will not be negative, it is positive only. And it must be an integer. It should be an integer. See example 1. Find the order and degree if defined of each of the following differential equations. The first one, dy by dx minus cos x equal to 0. And the second is xy into d square y by dx square plus x into dy by dx the whole square minus y into dy by dx equal to 0. The third one is y triple dash plus y square plus e power y dash equal to 0. Okay. The highest order derivative present in the differential equation is dy by dx. First, we have to write the order and then degree, right? So order means we should see the highest order derivative. Here we have only one derivative, it is dy by dx. So the highest order is dy by dx. We are differentiating y with respect to x only 1 time. So order is 1. What about the degree? We have only one derivative and its power is 1. So order is 1, degree is 1. Okay. And what about the second equation? Here in the first term, we are differentiating y with respect to x 2 times. Whereas in the second time, we are differentiating y with respect to x only 1 time. The third term also, y is differentiated with respect to x only 1 time. So highest order derivative is d square y by dx square. So what is the order? Order is 2. We are differentiating y with respect to x 2 times, twice. and its power is 1. So order is 2 and degree is 1. Order is 2 and degree is 1. What about the last equation? This is y triple dash means, what is y triple dash? How will you write? D cube y by dx cube. D cube y by dx cube. Y with respect to x 3 times. Okay. Plus y square. It's not a derivative. It's y square. Plus e to the power y dash equal to 0. So y is differentiated with respect to x thrice. Okay. Y is differentiated with respect to x thrice. So this is the highest order derivative. This is the highest order derivative. It is 3. And its power, its degree is 1. So order for this differential equation is 3 and degree for this differential equation is 1. Okay. Now see the exercise problems. The first one is d power 4 y by dx cube, dx to the power 4 plus sine of y triple dash equal to 0. Okay. Highest order derivative in this differential equation is, what is the highest order derivative? Y is differentiated with respect to x 4 times. So that is the highest order derivative. So order is 4. Order is 4. But can we define the degree? No, we cannot define the degree. It's not at all a polynomial equation. It's not a polynomial equation in its derivatives. Because I told you, right, it is sine of y triple dash. Sine of the derivative. It is not a polynomial equation in its derivatives. If it is a polynomial equation in its derivatives, then we will define order. We can define order. So for this equation, we cannot define order. It's not a polynomial equation. Next, determine order and degree of the differential equation y dash plus 5y equal to 0. Here the highest derivative. We have only one derivative, right? So y dash. Y dash means dy by dx. Its order is 1. As y is differentiated only one time and its degree also 1. Next, ds by dt whole to the power 4 plus 3s d square s by dt square equal to 0. So here the highest order is d square s by dt square. The highest order derivative is d square s by dt square because s is differentiated twice with respect to t. So the order is 2. Order is 2. What about the degree? Degree is 1. Okay. Degree is 1. Its power is 1. Next, for this equation, d square y by dx square the whole square plus cos of dy by dx equal to 0. Here the highest order derivative is d square y by dx square. It's a second order derivative. D square y by dx square. Y is differentiated with respect to x twice, 2 times. So this is the highest derivative. So order is 2. But what about the power? It's not 2 because it's not a polynomial equation in its derivatives. See the second term. In the second term, we have cos of dy by dx, cos of the derivative, cos y dash. So it's not a polynomial equation in its derivatives. Therefore, degree cannot be defined. Okay. See the next problem. Determine order and degree if defined for the differential equation d square y by dx square the whole square equal to cos 3x plus sin 3x. Okay. So first you simplify this equation. You rewrite the equation as d square y by dx square the whole square minus cos 3x minus sin 3x equal to 0. So what is the highest derivative in this equation? The highest derivative is second order derivative. It is d square y by dx square. And its order is 2. Okay. Its order is 2. Therefore, its power. What is the power of this equation? It's a polynomial equation in d square by dx square. And its power is 2, not 1. Degree is 2. The answer given here is wrong. This is the highest derivative, right? So order is 2 and the power is also 2. So degree is also 2. What about the next equation? Y triple dash the whole square plus y double dash cube plus y dash whole to the power 4 plus y to the power 5. Yes, obviously it's a polynomial equation, right? The moment we see the equation, we will identify that it's a polynomial equation in its derivatives y dash, y double dash, y triple dash. Okay. See the first term y triple dash. So y is differentiated 3 times. Y is differentiated 3 times. Okay. Whole to the power 2. And in the second term, y is differentiated 2 times. Y double dash means. Y dash means y is differentiated with respect to x only 1 time. And this is y to the power 5. No derivative here. So what is the highest derivative? This is the highest derivative. Y triple dash. Y triple dash. So order is 3. Y is differentiated with respect to x 3 times. So order is 3. What about the power? What about the degree? Its power, highest order derivative's power is 2. So degree is 2. Now come to the next equation. It is y triple dash plus 2y double dash plus y dash equal to 0. Obviously, this is also a polynomial equation in its derivatives y dash, y double dash, and y triple dash. Okay, the highest order derivative is y triple dash. Y is differentiated with respect to x 3 times. Okay, d cube y by dx cube. So order is 3 and its power is 1. Highest power is 1. So degree is 1. What about the next equation? Y dash plus y equal to e power uh, t. E power t. Whether it's a polynomial equation? Yes, it's a polynomial equation. We can define the degree also. Okay. What is the highest order derivative here? The highest order derivative is there is only one derivative y dash dy by dx. Y is differentiated with respect to x 1 time. So highest order is 1 and its power is 1. So degree is 1 and order is also 1. What about the next equation? Y double dash plus y dash square equal to minus 2y or plus 2y equal to 0. So what is the highest order derivative here? Y double dash. 2. Order is 2. And its power is 1. Even though we have square term here in the next term, y dash squared, but it is y dash. Okay. So we will not consider that. What about the last one? Y double dash plus 2y dash plus sin y equal to 0. Whether it's a polynomial equation? Yes, it's a polynomial equation. In its derivatives, y double dash, y dash. Sin y we can have, but sin of y dash or sin of y double dash we should not have. That's not a polynomial equation. Okay. So the highest derivative is y double dash. It is 2 and its power is 1. For the next equation, the highest derivative is d square y by dx square. Y is differentiated with respect to x 2 times. Okay. So its order is 2. What about the degree? Degree cannot be defined because we have the term sine of dy by dx. So degree we cannot define. For the next equation, the highest order derivative is d square y by dx square. Y is differentiated with respect to x twice. So order is 2. What about the degree? It is 1. Its power is 1. So which is the correct option? Option A. Here order only asked. So answer A. So we have discussed some problems based on order and degree, how to find the order and degree, how to write the degree and order of the given differential equation that we have learned. Next, I move on to solutions of a differential equation. Solutions of a differential equation. If there is any equation, then that can be solved, right? So if it is a differential equation, then that is also to be solved. Okay. So differential equation, solutions of differential equation. There should be a solution for differential equations also. What kind of solutions we can have? Okay. If I write that x square plus 1 equal to 0, see the first equation, x square plus 1 equal to 0, then there is a solution for this equation. How many solutions will arise for this equation? It's a second degree equation, second order equation or second degree equation, x square plus 1 equal to 0. Here order doesn't mean that derivative. It's a equation only, it's not a differential equation, x square plus 1 or x square minus 1, whatever. Okay, so for this equation, we will get two solutions for x, two values for x. As it is a second degree equation, x square, we have the square term. So when you solve it, you will be getting values for x, no? That values are nothing but the solutions. That values are nothing but the solutions. Why it is called a solution? When you draw the graph for this function, okay, you'll be giving values for x, no? So you'll be plotting the values in the graph sheet. The graph, you can see that in that graph, if the function where it crosses, that is called the solution, where it crosses the suppose this function can be taken as y equal to x square plus 1. If I take y equal to x square plus 1, okay, then I will give values for x. So I'll be getting values for y. Then if I plot the values where it crosses the x-axis, if x-axis means I will put y equal to 0. So that is called the solution, right? So for any equation, we can write the solution. That means we are solving that. You write any equation, then you should be able to solve it. So sine square x minus cos x equal to 0. This is a trigonometric equation. It involves trigonometric terms, sine square cos x. X square plus 1 equal to 0. How will you solve it? X square equal to minus 1. Square equal to minus 1. And minus 1 is further replaced by I square, because I square is minus 1. The value of I square, it's a complex number. I square equal to minus 1. So x square equal to I square means then I will get two values for x. It is plus or minus I. So x is plus or minus I means y value is 0 automatically, right? So I comma 0 and minus I comma 0. These two values are I'm getting. One is I comma 0 and one is minus I comma 0. So I comma 0 will be here. I means you have to consider the imaginary part. So imaginary part means it is 1, not I. You should not consider I. We cannot plot that. It's an imaginary value. So 1 comma 0. 1 comma 0 will be here. It lies on the x-axis. And minus 1 comma 0 will be here. It lies on the x-axis. Okay. So these two are the solutions for this graph. And if you give various values for x, then you will be getting the graph of this curve. Okay, but these two are the intersecting points of the given curve with the x-axis. That means these two are the solutions. Okay, so these are the intersecting points. So these two are the solutions. Like that, we can solve any equation. Okay, sine square x minus cos x equal to 0. Like that, we can solve differential equations also. Okay, so what are the two solutions arise for the differential equation? One is general solution and another one is particular solution. General solution and particular solution. What do you mean by general solution and what do you mean by particular solution? How I will arrive that? Now consider the equation y equal to a into sine of ax plus sine of x plus b. Not ax, sine of x plus b. Suppose this is, I am telling that this is the solution for this differential equation. Y equal to a into sine of ax, sine of x plus b. D square y by dx square plus y equal to 0. This is the differential equation we are considering. So when you solve it, you will be getting values for x or y. Obviously y, because y is depending variable. Y is depending on x. So that means we are solving means we are finding the values for y, not for x. Okay. So how will you write the solution for this equation? Y equal to. How will you write the solution for this type? Y equal to. Okay. Y equal to, y should be a function of x. Y will be a function of x. Okay. Suppose I am getting y equal to a into sine of x plus b. Y equal to a into sine of x plus b. Suppose I am saying that this is the solution for this differential equation, means I will say that this is a general solution. This is a general solution because I can see two constants a and b. Okay, two arbitrary constants, not constants, arbitrary constants. Arbitrary means what? Arbitrary means it can assume any value. A and B, I can give any values for A and B. So this is a general solution. So in a general solution, you'll be having arbitrary constants. Okay, that constants assume any values. Suppose if I give any particular value for these two arbitrary constants, if I give any particular values for these two constants, suppose I am assigning 2 for A and pi by 4 for B. Okay, then this will become 2 times sine of x plus pi by 4. Then this is called as particular solution because I'm giving particular values for the constants A and B. So then this is called as particular solution. Okay, so when you are solving the differential equation means you are solving it for y, not for x, or the depending variable. Okay, dependent variable. For this type of equation, you will be having two solutions. One is general solution and another one is particular solution. Okay, general solution means what? General solution means it will contain arbitrary constants or parameters. That is what general solution. If you give any particular values for the parameters, then that is known as particular solution of the given differential equation. So general solution means the solution which contains arbitrary constants. The solution which contains arbitrary constants is called the general solution. Okay. Any solution which contains arbitrary constants is called a general solution or primitive solution. Okay. What about particular solution? Particular solution means if you are giving any particular values to the arbitrary constants in the general solution, then that is known as particular solution. See one example. Verify that the function y equal to e power minus 3x is a solution of the differential equation d square y by dx square plus dy by dx minus 6y equal to 0. This is a differential equation. Y is the depending variable and x is an independent variable. Y is depending on x. Okay, only one independent variable. So ordinary differential equation. Highest order derivative is d square y by dx square. So order is 2. And what about the degree? Its degree or power is 1. So order is 2 and power is 1. Okay. The given function is y equal to e power minus 3x. You are asked to verify that this y will satisfy this equation. This y will satisfy this equation. Suppose if I say that x plus 4 equal to 0. This is the equation. Okay, then which one will satisfy this equation? For x, I can give 4. If x equal to 4 means then 4 minus 4 will become 0. So 4 is satisfying. So that means 4 is the solution, right? y equal to e power minus 3x is the solution. That means this should satisfy the differential equation. Okay, so for this I should find dy by dx. So what is dy by dx? Y with respect to x? If I differentiate, then in the right hand side you will be getting differentiation of e power exponential function as e power minus 3x. Then what is the constant? Minus 3. Then second term you are differentiating d square y by dx square, because I need to substitute it here for d square y by dx square. So again you will be getting e power minus 3x, and one more time you will get one constant. It is minus 3. So it becomes plus 9. Okay. So substituting everything in the equation, check whether it is 0 or not. So if I differentiate, this is the given function. Okay, I'm finding everything, dy by dx, d square by dx square, because these terms are given in the equation. So first I'm finding dy by dx. In the left hand side, if you differentiate y with respect to x, then you will be getting dy by dx. What about the right hand side? Exponential function. When you differentiate the exponential function, you'll be getting the same function, e power minus 3x. Okay, into what is the constant term? Minus 3. Okay, if you differentiate one more time, then the left hand side will become d square y by dx square. What about the right hand side? Already I have minus 3. If I differentiate e power minus 3x one more time, then I will get e power minus 3x only, but the constant is minus 3. Okay, when I differentiate e power minus 3x, then I will get e power minus 3x only, but differentiation of minus 3x is minus 3. Already I have minus 3, so it becomes 9. Minus 3 into minus 3 is plus 9. Now I'm going to substitute these two values in the equation. Okay, for this I will substitute 9 e power minus 3x, and for dy by dx I will substitute minus 3 e power minus 3x, and minus 6. What is this y? This y, for this y I will substitute e power minus 3x. So what you are getting? 9 minus 3, 6. 6 e power minus 3x minus 6. So I are getting 0. So LHS equal to RHS. It is verified. It is verified means then this is the solution for this differential equation. Since it is satisfying, it is the solution for the given differential equation. So I'll stop with this. We'll see the remaining in the next class. Thank you.